Hi everyone, Ms. Colasso here. So I'm making this video to go over the 5.4.3 lab on antibiotics. So I'm going to briefly go over what the lab is actually having you do, and then I'm going to go through every single question that you need to complete in the pre-lab and the post-lab. So in this lab, the problem is that there are three major forms of bacteria that are different, and we want to figure out the effects of antibiotics on the growth of those different bacteria. So we can identify the different types of bacteria based on how they're going to grow in the presence of antibiotics. There might be different colors, different scents, different colony groupings. So that is the goal, is to really just see the colony characteristics, shapes, groupings, and any other characteristics of the bacteria. So obviously we can't really do this lab now that we're virtual, but we could kind of do it hypothetically. So I'm going to kind of help us go through that. So in this lab, we would be setting up petri dishes with bacteria and incorporating some antibiotics just to see how the colonies grow. We do have to keep it at a stable temperature. So it would be in an incubator, and we would have it kept over time. So it kind of gives you a little breakdown about bacteria. I would definitely recommend reading this just to give you a little bit of background knowledge of different types of bacteria. So as you can see in this picture, here are three different types of bacteria. So the coccus one is kind of like circular. You can see their groupings are like that. The spirillum is more like a spiral, right? So we kind of see that in the name, so we could identify that shape. And the bacillus is more rod-shaped, so we could identify that and look at how they cluster, right? So already from these figures, we could see differences in the shapes, groupings of different bacteria. So the important thing that you need to focus on is this right here. So this is kind of the paragraph that's going to set you up for your lab. So since bacteria grow in almost any environment, you may be curious as to what is growing in a specific area, such as your cutting board in your kitchen, your dog's mouth, on your cell phone case. So what about the water that comes out of your tap? So it's kind of proposing all of these options for you to test and conduct in this lab. So what you're going to do for your pre-lab is you're going to choose one of these, or you could even do something completely different that's not mentioned here. But I really want you to pick an environment that you would want to sample bacteria on. So whether that's your dog's mouth, the rim of a coffee cup, a toothbrush, a toilet seat, whatever you want. And then you're going to compare. So that's basically the procedure. So select something that you would like to check the bacteria growing on. And then this is things that we would do in class that we don't have the ability to do, but it kind of runs you through the steps. Okay. So I'm going to take us right to the pre-lab. So your independent variable, and I'm just going to choose a different color. Let's do purple. So your independent variable is going to be what you're testing. So that's going to be what you found interesting that you want to swab the bacteria from. So I am going to do a coffee cup. I'm going to do a coffee cup and a toothbrush. So I'm going to assume that this is going to be the same type of bacteria because it's coming from the mouth. So maybe I'm going to change that from coffee cup and cell phone case, right? Because our cell phones could see a lot of different bacteria. We put them down everywhere, we touch them, put them on counters, they get really dirty. So make sure you clean your cell phones also. So let's do a coffee cup and cell phone case. So those would be our independent variables. Them themselves are staying the same, right? But we're going to change to see the bacteria on them. So our dependent variable, so what's being measured, this would be the growth of, I want purple. This would be the growth of bacteria. So we want to swab these surfaces and then check and measure the growth of bacteria for each one. So now for our lab setup, we need to, of course, have a control group. Okay, so there's going to be three different experimental groups. So you always want to have a control. That's going to be your standard, your baseline, so that you could really compare the other groups to the control group. Then you also want to have a group for each object. So we could have a coffee cup and a cell phone case. Cell phone case. Okay? And you're just going to do one trial for each one. So one. Oh, I wish I didn't have to change the color for every. That's okay. So I realized when you copy and paste a lab, this table might not come up. So I want to show you real quick. You just go to Insert, Table, and then you could do 4x2. And that'll give you this table. And you could just click very easily in each box. Okay? So control, what is the experimental group being compared to? So this is going to be, and let me just change my font real quick. So this is going to be an agar plate. So you're going to be using a wet cotton swab. And basically you're going to follow exactly the same procedures. So you want to follow the same procedures because you want it to be controlled, something you could equally compare it to. Same procedures as experimental groups. Okay? And you're going to add, and oh, sorry, it's a period. And you're going to add antibiotics to half of the plate. So that's exactly what you're going to do in your other experimental groups, but now this one just isn't going to have that bacteria. It's just going to be the agar plate. Okay? So hypothesis. So we actually talked about this in the beginning of my time with you guys. So hypothesis is always going to be in an if-then format. Or you could do if, then, because. I think you guys actually taught me that you always add the because at the end. So you could kind of get creative here, but it gives you a nice little template or, a frame for you to use. So you could say if, so independent variable, let's say cell phone case. If cell phone case is swabbed, and a coffee cup is swabbed, right, because we have two, then there will be no difference. Actually, no, there would be a difference. There will be a difference in the kind and amount of bacteria that will grow on the agar plate. So the cell phone case, we're hypothesizing that the cell phone case and the coffee cup are going to have different kinds and different amounts of bacteria. Had we done the coffee cup and the toothbrush, it would probably be the same, right? Because it would both be bacteria that's coming from the mouth. But I think, so you could do either one. I just think this would be a more interesting lab to do. So now we have to do our lab title. So that is just like to give you an example, the effect of independent variable on dependent variable. So you could say the effect of swabbing a coffee cup and cell phone case. So those are independent variables on the growth of bacteria. And maybe we want to add a little comparison. So the effect of swabbing a coffee cup and cell phone case. Coffee cup compared to a cell phone case, I think. Compared to a cell phone case, right? Because we want to compare the bacteria between these two objects. Okay? So moving along, experimental constants. So these are things that are going to stay the same. So you need at least 6 variables that are not altered. So let's just make a list. So we're using the same agar. The cotton swabs are the same. Same water, right? Everything, all of these things don't change. Same source of antibiotics. All petri dishes are going to be the same. Same temperature, right? If we have it in an incubator, we don't want the temperature to change, so same temperature. And there's 6, okay? So you have that. Sketch of experimental setup with labels. So really, you could add a drawing for this. I would go back to that lab. Let me show you. And I would actually copy and paste this figure if you wanted to, just so you have an image there. But because we're not doing this, it's kind of hard. You could also, and I'll show you. You could insert, let's do a little drawing. And you can make 2 petri dishes if you, or you can make 3 actually, because we want to have, so you could have like 1. Okay, so I'm just going to copy and paste that over, make it easier for myself, right? So we have 1, 2, 3. Okay, and then all you want to do is label them. So you could have like control group. And then same thing, guys, you could just copy and paste, make it easier for you for yourselves. That over. And then you could just change the wording in each one. So we could have our control group. We have, oops, coffee cup and cell phone case. And you're going to want half of this to be, let me see how I could do that. So maybe you can make a line. So you want half of it to be antibiotics. So let me see if I could, right? So you could just create a line, same thing, copy, oops, paste, drag that over. So you could do this very quickly because you're just making 3 of the same thing, okay? So that's what we could do. It's kind of like a setup. That looks kind of nice. You could obviously add like the bacteria. You could write antibiotics. You could get really creative with it. Just for the sake of time, I'm not gonna go through all of that with you, but just to show you how to actually make a drawing and put the sketch in if you wanted to. Okay, so now we're gonna write out our procedures. So this is I'm just gonna do it by each question here. So let me change my color again. So it's asking us to make sure we answer these questions. So how many plates are needed? So we need 1 for the control and 2 for experimental, right? Our 2 independent variables. What samples will be taken? So we said that and we could type this out. We will be taking a sample from the rim of a coffee cup and a sample from a cell phone case. Okay. And then what is on each plate? So we are going to have the swabbed sample for each group. Antibiotic, agar, and I think that's it. Oh, and distilled water, right? That's going to be on each plate. What antibiotic disc will be used? So, I mean, they kind of are saying that you'd be provided with that. I would just say that the disc is going to be on 1/2. So disc will be on 1/2 of, okay, and there you go. So now we're going to fill out this table, okay? So swab location. So we could put both of our independent variables. So we could have rim of coffee cup and cell phone case. Number of colonies. So this is where we kind of have to guess a little bit because we didn't actually do this lab. But your number should be between 1 to 15. You could see more, but I would say put like 5 or 6 to be safe, okay? Like I said, this is going to be all hypothetical. So this would be after we conduct the lab. So now we have our bacteria incubating. They're being cultured for a certain amount of time in that temperature with the antibiotic, half of it antibiotics, half of it by itself, and we're going to see the colonies. So in some, we might see that in antibiotics, the colonies actually increase or that they decrease compared to the other side without antibiotics. So that would be really interesting to see. So description of colonies. So this is where you could go back to the lab and kind of use these images for your description. So you could say, oh, they were like small circular grouped close together, right? So small, circular, if you wanted to say that one, close together, or you could choose one of the other ones. You could say rod-shaped, something like that. Control disc growth. So you could say the bacteria grew all around, something like that, because it's controlled. So we know that the bacteria is just going to grow, and the antibiotics aren't, well, they might. But yeah, there's not going to be much difference here in this control group. Whereas for antibiotic 1 growth, that would be the first one, there might be a halo around the disc containing no bacteria. So there may be parts of disc with no bacteria growth. And same thing for antibiotic 2. So parts of disc with no bacteria growth. Okay, so that's going to happen with the antibiotics. They might actually be able to prevent the bacteria from growing. So you might see kind of like bald spots on the disc. Okay, were you able to grow individual colonies? If so, describe their appearance. So again, this is something that would be probably more helpful if we actually did it, but we could be hypothetical again. So for this, we'd want to look for differences in the growth, color, texture, edges, the smell of it. So you could say yes, we were able to grow individual colonies. You could say they were orange appearance, small. You could say they were a little fuzzy looking, yeah, so I think that would be good. Just kind of like come up with characteristics that you think that you would see in the bacteria based off of what we would see here. Okay. So next question, how did the antibiotic disc affect the growth of the bacteria? So there were some, you could say there were some areas with no bacteria growth and some with a lot of growth in colonies. Okay, so it definitely depends on the bacteria. But like I said, this is hypothetical, so you could be a little bit more vague with your responses. Okay, so third question, did you grow anything else besides bacteria, fungus, or molds? I would say no, just because fungus and molds would actually take a really long time to grow, so did not have enough time. Right, we just want to say that we did this lab quickly, definitely didn't have enough time for fungus or molds to grow. Maybe a little bit of molds, but yeah, probably not. What was the that should be what was the purpose of the control disc? So this would be to see if there is any bacterial growth without antibiotics. Okay, so like I said, the control disc is not going to have the antibiotics, so we want to see if bacteria would still grow, and we could say that it did. What else would you like to test for the presence of or absence of bacteria? So you could get creative here. Now you could say, oh, I would really like to test my dog's mouth, maybe my toothbrush. Anything else that you'd want to test for bacteria. It literally could be anything, countertop. So you could just get creative here. It's kind of more like opinion. All right, so that's the lab. I tried to make this video short for you guys so it was more digestible, but definitely take this lab as slow as you need to. You could rewatch the video, pause it to fill out the questions, but this is all here for you. Okay, please email me if you need any other help with this lab. Okay, bye everyone.